Alright, here's your homework on square root and cube root functions to be able to analyze and graph. So this is describe the transformations from this parent, from the parent function to this. So the parent is the simplest form, and it would only be root x. So I look at two things. First, I look underneath the square root sign. It's just x, no change there. I look in front and behind. So what's multiplying in front is a vertical stretch. It affects the y values. And it's a vertical stretch by 2. What follows outside the square root again also affects the y, but this is going to be a vertical shift. And this is going to go what it says, which means it's going to shift down 9. Number 2. This is for a second. Cube root function. What's underneath the cube root sign affects the x. So that means it's horizontal. In this case, it's a horizontal shift, and it's the opposite direction from what I see. So the direction is going to go to the left 5. In front, I see a negative. That's going to be reflection. And that's going to reflect across the x-axis. If the negative was inside, it would reflect across the y-axis. And then I see plus 3 on the outside. So it's on the outside, so it's vertical. And it's just shift, and it does what it says. So it's going to go up 3. Number 3. Can we work backwards? So can you start with a square root function and then do the transformations and see what the equation will look like? So first of all, it's been vertically compressed by a factor of 1/3. Then translated so that it has an endpoint at 4, -1. So normally the endpoint would be at 0, 0. Write an equation that could represent this function. So you can use y or f at x. The 1/3 is going to be multiplying in front. You could also write that as a denominator of 3. But if it's 0, 0 and changed to 4, that means that the x's you added 4. But underneath you have to do the inverse of what you see. So what shows that you added 4 to all the x's? 1, that's -1, does what it says. So you're subtracting 1 on the outside to change the y's. Number 4, the cube root parent function is reflected across the x-axis, vertically stretched. So first of all, we reflect on the x-axis. Vertically stretched by a factor of 3, then translated 8 units down, write an equation. So one step at a time. So if it's been reflected across the x-axis, it's a negative on the outside. Vertically stretched by 3 is also on the outside, so a big -3 on the outside. And then it's been translated 8 units down. So there's nothing that's affecting the x. So the x underneath the cube root sign stays the same, and I have to subtract 8 on the outside. Be careful that this 3 is quite large compared to the little 3 in the radical, so that it doesn't look like they're the same size. All right, number 5. Can you graph a square root function? So a good place to start at the parent point. So that's 0, 0. 1, 1, and the square root of 4 is 2. Nothing is changing the x. So I look under the square root sign, x stayed the same, no changes. I look outside the square root sign to see what affected the y value. So each y I'm going to subtract 4. I do what it says. Then I'm going to plot those points. So my new starting point is at 0 and -4. Then 1 and -3, and then 4 and -2. So we have a starting point, and it curves away from there. So there's only one arrow for a square root function. So you have a starting point and it curves away from that starting point. So the domain in this case, well, the x value, that's 0, and it goes to infinity. The range, what's the y value there? That's -4, and it's included, and it goes to infinity, going up forever. Where's the end or turning point or the starting point, really? Well, that's at 0 and -4. That's where you would start the graph. As x approaches infinity, what's the right end approaching? And the answer is infinity. As x approaches, now it wouldn't be infinity in this case, because our starting value is what number? 0. So as x approaches 0, what is the y value approaching? -4. So where is this increasing? Well, it's increasing everywhere. So it starts increasing at 0, and it goes all the way to infinity, rising the whole time, and there's nowhere that it's decreasing. All right, number 6. Start with the parent points. So inside tells me I'm going to subtract 2 to all the x's. So 0 subtract 2, 1 subtract 2, and 4 subtract 2. On the outside, it affects the y value. So I'm going to ultimately change the sign or multiply by -1 to change. So 0, there is no sign to change. -1 and then -2. That creates a reflection. So first I'm going to graph. So it starts at -2, 0. Then it's -1, -1. And then it's 2 and -2. So follow the path. It's going to look like it's been reflected. So it's like the bottom curve of a sideways parabola. So the x value that started with -2 and it goes to infinity. The range, the bottom of the range is actually -infinity, and the top of the range is 0. I know, you have to think twice about it. The point that we started at was at -2 and 0. The end behavior, so as x approaches infinity, the function's going to -infinity. And the other way, the x value of our starting point, so as x approaches -2, the function is approaching 0. This is not increasing, but the whole function is decreasing, starting at -2, going to infinity. So it's falling throughout. Turn the page. So now it's the time for you to start. So we need to know the parent points. So write them down, and then press pause and transform them. Then press play. So under the square root sign, I'm going to subtract 3 to all the x's. And outside, I'm going to go times 2, and then I'm going to add 1. So 0 times 2, and then add 1. 1 times 2, add 1. 2 times 2, that's 4, add 1. So I'm going to start at -3 and 1. I'm going to go to -2 and 3, and 1 and 5. I'm going to draw. It's important that when you draw the square root, you don't start before it. You start at the starting point and curve up or down from there. Our domain, what's the lowest, smallest x value? -3, and it goes to infinity. Our range, what's our smallest y value? It's 1, and it goes to infinity. Our starting point was at -3 and 1. So as x approaches infinity, the function approaches infinity. The second part comes from your starting point. So as x approaches -1, the function approaches 1, or -3, the function approaches 1. Increasing, well, for number 7, the whole function is increasing. So where does it start? What x value does it start? At -3 and then to infinity, and there's nothing that's decreasing. All right, number 8, cube root. So for cube root, we do have a 0, 0. That's called a point of inflection. But the other points we're going to use are 1, 1, -1, -1, 2, 8. Oh, sorry. Try the other way. 8, 2, and -8, -2. There we go. So you can see some similarities, but cube root you can take the negative number of, and the cube root of 8 is 2. So for this, the domain and range are all real numbers, and that never changes. So we can write that in. So it goes up forever, down forever, left forever, right forever. Now, underneath the cube root, I'm going to add 1 to all the x's. And then I'm going to plot these, if they fit on my graph. So I added 1 to all of them. So my most important point is the point of inflection. So in this case, in terms of understanding the turning point, this is really called a point of inflection, and that's at 1, 0. So that's the most important point, because it changes from smiling to frowning or vice versa. We see the concavity changes at that point. So we have 1, 0. We also have 2, 1, and 0, negative 1. We have 9, 2. And we have negative 7 and negative 3, or negative 2, right there. Okay, so you can see this is kind of going to look like an S. So on one side, it kind of frowns, and on the other side, it kind of smiles. So you can see right there at that point of inflection, it changes how it curves. So you curve up, and then you curve down in a way that concavity changes. Now, so as x approaches infinity, the right end goes to infinity. As it goes left, it goes down. This whole thing is increasing from negative infinity to infinity, and there's nothing that's decreasing. So from left to right, the whole thing is going up. All right, number 9. Start with the parent point, 0, 0. That's your point of inflection. 1, 1, negative 1, negative 1. And then 8, 2, negative 8, 2. Look inside, so we're going to subtract 4. So I'm just subtracting 4 to each one. I think negative 12 would be off my graph. And then I'm going to, there's a reflection, and subtract 2. So 0 has no reflection, so I'm just going to subtract 2. Here, it's going to be negative 1 and subtract 2. This is going to be positive 1 and subtract 2. Negative 2, subtract 2, and this one I don't think will be on my graph, but negative 2, subtract 2. Oh, this is a negative right there. Sorry. So negative, negative is positive 2, subtract 2, which is 0. So our domain and range are not changing. It's all real numbers for both. It goes up forever, down forever, left forever, right forever. No breaks, no jumps, nothing. So end point or turning point is really the point of inflection, and our point of inflection is at negative 4, negative 2. So that's the most important point. 1, 2, 3, 4, and negative 2. And then we have negative 3, negative 3. And we have negative 4, negative 2. So there's those points. We also have a point at 4 and negative 4. And then the other one will be off my graph. So 12 is like, negative 12 is like there. Alright, so graph it to the best of your ability. So as x approaches infinity, the right end is going down. To the left end is going up. So this is only decreasing, not increasing at all. So these cube root functions are monotonic. They only decrease or only increase with no turning points that would change the direction. Instead, we have what's called a point of inflection. And what that does is it changes from frowning to smiling when I do that. All right, last one to practice graphing, number 10. So in number 10, cube root. So we're going to start with 0, 0, 1, 1, negative 1, negative 1, 8, 2, and negative 8, negative 2. So underneath the cube root sign, it's only x. So x's all stayed the same. So I'm just going to rewrite every x. They've stayed the same. The y's, 3 over 2 is 1.5, and then I'm going to add 5 to it. So see if we can do that. So 1 times 1.5 is 1.5. And if I add 5, it's now at 6.5. Negative 1.5 plus 5. Now we're going to go the other way. That is 3.5. 8 times 1.5. Well, 2 goes in 8. 4 times 3, it's 12. And add 5, that's 17, probably off my graph. So again, when you have a fraction, you can multiply and divide, or divide first. So I'm dividing. So negative 8 divided by 2 is negative 4, and then times 3 is negative 12. Add 5, and it's negative 7. So that one will likely be on my graph. Oh, for here, for 0, 0 times 1.5 is 0, but add 5, and there's our point of inflection. So we'll start there. So 0, 5 is our point of inflection. We already know the domain and range do not change. They're all real numbers. So we have 1 and 6.5. We have negative 1 and 3.5. We have 8 and 17. That's not on my graph. But negative 8 and negative 7. That will be on my graph. So what did I do wrong there? Negative 8 and negative 7. So negative 8, negative 12 plus 5, that's negative 7, right? Seems like that one's way off. So what am I doing wrong here? Negative 12 plus 5 is negative 7. So negative, oh. All right, let's try this one again. I was using 8 instead of 2. So let's correct myself. So 2 divided by 2 is 1, which is 3, and 3 plus 5 is 8. Oh my goodness. Negative 2 divided by 2 is negative 1, times 3 is negative 3 plus 5, which is 2. Let's get my head on straight. So 8, 8. And ignore that. Negative 8 and 2. Now that's starting to look like something I can do and make the curve. So if the pieces aren't coming together, then you have to edit yourself, right? Go back. Where did I make the mistake? What silly thing did I do? And then complete it. So there's your graph. So the end behavior as x approaches infinity, the function approaches infinity. As x approaches negative infinity, goes negative infinity. It's monotonic. It's only increasing all the way through, and there's nothing decreasing. All right, I'll do a separate video here in terms of understanding square root functions and cube root functions. But anyway, that was your homework. I'm glad you did your homework with me. Mr. G Math, over and out.